So today class we are going to discuss about IGBT. What is IGBT? Insulated gate bipolar transistor. Insulated gate bipolar transistor. It's a transistor. It's a FET, MOSFET and IGBT. These three also coming from the transistor only. So last class we are discussing about MOSFET. Okay, MOSFET is a voltage control device. What about IGBT? IGBT also voltage control device. IGBT also voltage control device. Okay, how the IGBT is developed? IGBT is nothing but it's a combination of BJT and MOSFET. It's a combination of the BJT and MOSFET. So these two is combined to develop is called IGBT. Okay, so you know BJT is a current control device, MOSFET is a voltage control device. So these two is combined to develop is called IGBT. It's a current control device is a BJT, MOSFET is a voltage control device. So how it is combined? We'll see how it is combined. This is a method to combine it. It's a method to combine. What is that one? I am used for that one MOSFET and I am going to use for that one BJT. Inward direction. So inward direction means N is in central. Sorry, not central. Okay, center is N. So PN. So PNP transistor. Okay, it's a transistor. PNP or BJT. You can say bipolar junction transistor. Okay, is used. It's a combined. So why IGBT is a voltage control device? Why should not a current control device? Excuse me. Because input side is a gate. So gate is used. That's why it is a MOSFET is used. MOSFET is used for the input side. That's why it is a voltage control device as similar to that MOSFET. As similar to that MOSFET. So voltage phenomena. So you will going to apply for that gate to the emitter. What is the terminal? See, collector is coming, emitter is coming, and gate terminal is coming. So these three terminal. This is a three terminal. So I will take the pencil. Okay. So you have see that one. So you can draw the symbol of that one. So this is a gate terminal. Yes, you can draw about the gate terminal. And here you will going to draw the one transistors. So I will going to draw the transistor. That's all. Okay, but you know this is a method of the connection about the transistor, but I will going to draw the transistor here. Okay, so transistor is a collector terminal, another one terminal is a emitter terminal. That's all. So arrow mark is normally coming on that emitter terminal place. It is coming normally arrow mark is outward direction means it's a P is coming here. N type of the transistors. So this is a method to develop the symbol of the IGBT. IGBT symbol is developed. How it is developed means MOSFET plus BJT. So this is a inside the construction part. Okay. Then why it is a voltage control device? Because input side is a MOSFET is a take place. That's why it is a voltage control device. Voltage phenomena. Okay, fine. So this is a symbol of that IGBT. Okay. And further you have see that one. So inside normally I am also arise one questions. Okay, why the here is in that arrow mark is there in the collector terminal? Why should not there in emitter terminal? So it is there. It is inside the construction. The inside of this is called it's a developed IGBT. You don't do on that one. Don't take about that one MOSFET and one BJT. Make the connection. No. So it is developed inside the pot, and then there finally this is IGBT is developed. So this is a developed device is came. What is there inside means this is there inside. So inside about that construction part is there inside. So two transistors they are using PNP transistor and NPN transistor. So like they are going to develop and constructed, and the final outcome is this is symbol is final outcome. Okay, fine. This is about the IGBT. So okay, this is the first line. Then another one is it's a gate. It's a voltage control device. Okay. Then next one. So compare with the MOSFET. So compare with the MOSFET and then BJT. If you have see that one better conduction characteristics. The IGBT is a better conduction characteristics. Compare with that MOSFET. So MOSFET you have compare it's a better conduction characteristics. Another one is what is the speciality about IGBT? Another secondary breakdown. So it's not having the long switching time. So secondary breakdown is very short. Okay, very short about the switching time on that secondary breakdown. Okay, that's all. So emitter you will going to apply the voltage to, you will going to trigger the IGBT. Okay, the next one. So coming to that one, it's a combination of MOSFET and then BJT set. So what is the merits of MOSFET? High input impedance is the merits of the MOSFET. It is a taking. Okay. Another one is a BJT. BJT is a low state low state. Okay, power loss. Okay, low on state power loss. So these two is combined is a merits. This merit is coming to that IGBT. So merit from that MOSFET high input impedance and BJT is a low on-state power loss. So these two is combined together to develop this IGBT. So this is a specialty. Yes. Then next one we're going to see, next one majorly we about the construction. So I have so about that one MOSFET construction only. So NPN, it's a transistor of NPN only. So here is a source, here is a drain. Okay, this is I'm going to explain about MOSFET construction only. So drain is there, source is there. This is a body is nothing but a source only. So here is a P in the P is attached to the gate, not directly attached to the capacitor, that is called a SiO2 layer attached to the gate terminal. Okay. Another one is you have see that one, this drain terminal. So here, okay, N and here is a N minus. So N minus is a take place. What is N minus? It is called as a drift layer. This is called a drift layer. So you will going to draw very big diagram. Yes, I have drawn about the very bigger size of the diagram. So drain after that N plus, yes, N plus is there, and N minus. So N minus is called a drift layer. Why you are drawing about the drift layer? So if you want to go for that higher ratings means drift layer you need to draw. So power MOSFET, if you want to develop about power MOSFET, go for that drift layer. That's all. Drift layer is present. So what is another specialty about the drift layer? It's a switching voltage handling capacity is increased. So switching voltage handling capacity means nothing but what is that one? Higher power rating increase. So capabilities to handle for that higher power rating. That's all. Okay, then coming to that one, this is called a MOSFET. What is IGBT? The same, similar, you can take it. So this N plus is where is that? What is N? This is N plus. So this is N plus is connected to the drain. It is replaced into the P plus. That's all over. So N plus is replaced into the P plus. So you will going to replace the N in N plus is replaced into P plus. This is called IGBT. And one more things you want to do. Well, do you know symbol of that first MOSFET? So MOSFET symbol is this is MOSFET gate terminal, and here you will going to draw. Okay, so here is a yes. So these two is joined, and this is a upper side. This is a drain. I can't draw. Oh. Okay, this is a drain. This is a source. So what is a source? Source is a common. Source is common for that ground. Input as well as output. Common terminal is a source for that ground terminal. Similarly, next one we will going to draw about that IGBT. How to draw gate terminal? Okay, another one is a output side is a BJT. You will going to draw. You mean transistor? You can draw. Okay, another name of the BJT is called transistors. Yes. So collector terminal and the emitter terminal. So what is that one? Emitter terminal side arrow mark. So I'm inward or outward you will going to mention it. Okay, no problem. So now you can compare these two symbols. So the drain place is replaced into the collector. Drain is a terminal is replaced into the collector terminal. Where is a drain? You can replace into the collector. Drain is replaced into the collector terminal. Another one is a source. Source is replaced into the emitter. Where is a source? Source is replaced into the emitter. That's all. Just rename it. Source is where is a source? N plus is called a source. Yes, N plus is called source. The source terminal is replaced into that emitter. That's all. This is about the IGBT construction. Very simple. Once again, I will repeat you. The N plus layer is replaced into the P plus layer. If you are going to replace means that is called the IGBT. The same as it is ditto. Then you can see that a symbol. So drain terminal is replaced into the collector terminal. So drain is strike out and write the collector. And source is replaced into the emitter. Source you can strike out, write the emitter. That's all. This is a very simplest construction about IGBT. Okay. So for again I will going to show you here. What is that one? This is called MOSFET. In the MOSFET, what is that one? What I want to do? See, in the circuit I will directly go ahead. So N plus is replaced into the P plus. That's all. Okay, P plus is replaced. So drain terminal is replaced into that collector terminal. That's all. And the source terminal is replaced into that emitter terminal. So emitter terminal. Yes. So now it is over about that IGBT is over. This IGBT construction is over. Okay. Then first one. Okay, the construction part is over. Okay, here is N minus layer is there. So drift layer is there. Okay, next one. Okay. Then next we'll go for the operation. So in that operation or function or working, whatever you can word you can use it. In the working, what you will going to do? First, initially I am not apply the gate terminal. If no gate means what about output? No, nothing is output. Voltage will come. So if I am going to increase the voltage will go, it is a potential difference of the point is take place, but current is not flow. Why current is not flow? Because you are not apply the gate terminal. If you are not apply the gate terminal, what is the problem? If you are not apply the gate terminal means the switch is not closed. Okay, if I will going to apply the gate terminal, okay, gate is applied. What is it? I will going to give the required voltage, for example 2 voltage. If I am going to give the required voltage on the gate terminal, okay, now switch is closed. Then switch is closed means in the construction how it is working. So from the collector to terminal 2 directly it's a flow. Okay, it is a flow like it is a flow to the closed circuits. That's all. It's a flow to the closed circuits. Okay, yeah. I will repeat again once again operation. So operation of that circuits. Okay. So what is that one? First one, no gate terminal is applied. Okay, gate terminal is not applied. If I will without apply the gate terminal, okay, in that one RPS, okay, drain collector to emitter, you will going to do the power supply. When you will going to do the power supply collector to emitter, what will happen? Potential difference between these 2 points, voltage is present, but current is not flow. Current is not flow. Okay, if current is not flow means, okay, it is a circuit is not closed. Why current is not flow? Why current is not flow means the switch is, the MOSFET switch is not closed. The switch of the MOSFET is not closed. Okay, I will go ahead on the static characteristics diagram. You will going to understand. Yes. See, for example, first step number 1, I am not apply the gate terminal. Gate terminal is not applied means what happened? So here you will going to use that one. Okay, here 1 voltmeter you can connect. The potential differences take place. So potential difference. So Vg is 0. Potential is take place. Okay, but current is not flow. Okay, what to do? Then you will going to increase the voltage. You can apply for the minimum voltage. For example, 2 voltage. Yes, I have increased. Then I have applied for the 2 voltage. Okay, once you applied, this gate terminal is closed. Yes, once you close the gate terminal, what will happen? So this source is a flow.
You are currently the only current person in this conference.
Circuit is closed. That's all. The switch is closed. Once 2 voltage is applied, the switch is closed. Due to the closing of the switch, current is a flow. The current is a flow. Okay, that's all. Okay, so this is about the working. Okay, this is about the working. So what is happening inside? If I am going to apply the 2 voltage, what is happening inside? So gate to the emitter is, I have applied the 2 voltage. Yes, you can apply for the gate to the emitter 2 voltage. Then what is happening inside? You know, so from VCC to the load to the collector terminal to emitter terminal is flowing. Collector terminal to emitter terminal is flowing. How it is flowing? Can you tell me some more idea? So yes, it is a flowing like that one only. It's a flow. This is the direction. Okay. See, like it is a flow. Okay. What is this terminal? Here is a plus is coming. Here minus is coming. Why it is coming? Why it is coming? Do you remember in current layer? I explained about MOSFET in current layer. It is one of analogy. Push type of the tap. Push type of the tap. When you will go to light push or heavy push, or if you will going to push this more, then what will happen? The water is more output, from input to output is coming flow more. See, this is due to that one. When you are going to give the source to the gate with respect to the emitter, the circuit is closed. Due to the close of the circuit, what will happen? This is a capacitor I said. So plus terminal as well as minus terminal is formed. So due to the minus terminal is formed, here is a plus terminal. So these two is interacted. The circuit is open. Due to the open the circuit, so current is a flow from collector terminal to the emitter terminal. So this is a reason to flow the current freely. Okay, so these are the construction as well as operation of that IGBT. So very simple. If I have say about that, understand about the MOSFET, the IGBT is similar to that one. Yes, that is a difference. And furthermore, some more points you will going to write. So you will going to okay, here is a P plus layer, N minus layer, here is a P layer is there, okay, here is the N layer is there. So you have to see that one, this is junction 1 and this is a junction 2, junction 1 and junction 2. So okay, this is in current layer or injection layer is there here, injection layers, okay, injection layer, okay. So here is junction 1, junction 2, okay, next one. Some more point I will going to add you. Okay, this is a drift layer, okay. So not here, it is in current layer, it's injection layer. In current layer means what is the in current layer? Gate with respect to emitter terminal, when you will going to apply for that one here. So power supply minus with respect to the plus. So gate with respect to the emitter terminal, this is emitter terminal. So once you will going to apply, here is a plus terminal is formed. here is a plus terminal is formed. So here is a minus terminal is formed. Here is a minus terminal is more minus is formed. So this minus and plus is it will going to make to the connected. So connected to this box is open. So once this box is open, okay, why this box is open? Due to the in-current layer, this box is open. Okay, why this box is open? Due to the in-current layer, this box is open. Due to the in-current layer, this box is open. Why the minus is present? Due to the in-current layer, minus is present. How it is a present? So here apply the source. Gate is a positive with respect to emitter. When you will going to apply the source, what will happen? So here you will going to minus is create. Similarly here also there. Yes. So here also, okay, gate is a plus and the minus is connected to that emitter. So what will happen? So here also there. So here also minus. So this side also open. So once it is open means what will happen? Freely flow. Train is started, yes, freely flow. Yeah, like it is a freely flow. Okay. Yes. Okay, coming to that one. Okay, so initially VG, okay, input voltage is not, okay, input voltage if you are not apply the input voltage, this current is flowing is not possible. The switch is not closed. Okay, theoretically if I say it's a forward bias, this is a reverse bias, forward bias, reverse bias. Okay, the switch is not a breakdown. When the switch is breakdown, when in-current layer is take place, the switch is breakdown. That's all. So this is about that. Some more points about that. This is a method. Okay. Yeah. So static characteristics. Generally, there are two type of characteristics. One is a static characteristics. Another one is a dynamic characteristics. This is where is that one? Switching characteristics is called dynamic characteristics. So dynamic characteristics nothing but a switching characteristics. So first we will going to look at shortly about that static characteristics. Yes, this is a diagram. So input side, gate terminal, triggering circuit, resistance type of the triggering method you can apply. Okay, for example, 2 voltage I will going to vary this resistance to. I will going to give the 2 voltage input side. Okay, once I will going to give the input side means what will happen? Okay, the switch is closed. The switch is closed. Once okay, the switch is closed. Now the flow of current on that output of the current, and here is a what is about that one? Here the voltage, you will going to measure the voltage. Okay, you will going to see. So output current versus the output voltage, you will going to draw output current versus the output voltage, you will going to draw. That is called what is that one? That is called output characteristics. That is called output characteristics. Output current versus the output voltage. Once I will going to apply the 2 voltage, then only what will happen? The switch is closed. Okay, once the switch is closed, what will happen? I will going to vary. So slowly increasing output current as well as output voltage. So slowly it will going to vary. Slowly it will going to vary. After that, what will happen? So further you will going to vary the resistance. The voltage is maintained as the voltage is increased, but current is maintained as a constant. The current is maintained as a constant, output current is maintained as constant, but voltages keep on rise it. Okay, so this is this natural characteristics of the output characteristics of IGBT. The next one, transfer characteristics. What is the transfer characteristics? Input voltage and output current. Output current and input voltage. Output current denoted IC. Yes. Another one is input voltage denoted G2E. VGE is written. So what is that one? So less than 2 voltage. It's a threshold. Less than 2 voltage means switch is not closed. Switch is not closed means no output current is 0. That's no output current is a flow. So 0.0, 0.5, 1 voltage, 1.5 voltage. Output current is 0 only. Then 2 voltage. 2 voltage is supplied. The switch is closed. Once the switch is closed, the current is a flow. Once you close the switch, the current is a flow. So further you have increase. What will happen? Your output current is increased. Your output current is increased. Input voltage is maintained. Input voltage is maintained because once triggered enough. So output current is increased. Input is maintained enough. Okay, fine. So this is about that static characteristics. Then we'll going to see about that. Next characteristics is dynamic characteristics or switching characteristics. So look out the picture as usual. I said about that one MOSFET, the same picture I show you. So explain about the picture. You will going to explain about the picture. So what your grandfather is doing? He is simply standing. The grandfather is simply standing on that one. Okay. So like you can say he is one of the family members. What they are doing? So here one person is taking rest. Okay, father is I think he is using the mobile phone. Okay, so mother is doing some work. Okay, so like you will go to there are small three members in your family, they are sit together. Okay, and he's enjoying on that one in his vacations, and he's also during the in park place also he's working. So you will going to start to explain after seeing this picture. You will going to explain like, excuse like you will going to explain about, so dynamic characteristics. Dynamic characteristics is very simple, but only one thing you want to know this once. Okay, or another name of the dynamic characteristics is called the switching characteristics. Just you can want to see and then start to write, that's all. Just to see it and start to write. As usual, MOSFET on time and off time. Every device has the on time and off time. It's controlled on and controlled off. What is on time? Delay time plus rise time. Delay time plus rise time. What is off time? In that MOSFET you have seen, okay, delay fall time and fall time. Delay fall time and fall time. But here is a two device you are going to know, MOSFET and the BJT is used. That's why delay fall time and fall time 1 and fall time 2. There are two fall time. So fall time 1 and fall time 2. So T on is equal to delay time plus rise time, and T off is equal to delay fall time plus fall time plus fall time 2. Okay, this is combined. Okay, if you want to get that full mark, I am going to find out one of the method. This is a method. Okay, draw the diagram and take this tabulation. Enough, you will going to prove you are understand. That's all. It's very simplest method. Okay, I have on time. This is called on time. Only I have draw this written about the tabulations. This tabulation is explained about very simply what is there inside in the diagrams. So this is called the input VGE. VGE means what is that one? Input voltage. Then output current. What is output current? IC, collector current. Collector to emitter voltage is called the output voltage. Output current, output voltage. So this is called the output characteristics. Output characteristics. This is a input voltage and output characteristics. Here I have written input voltage, output current. So just you will going to fill that one. That's all. So during the delay time, this is a part. Where is the delay time? This is a part about the delay time. So during the delay time, what is the response about the input voltage? What is the response about the output voltage and output current? Just you will going to fill that once. Okay, very simple. Need not to you will going to what you have seen. This is a picture. So what this family is doing? There are in the family there are three members. Okay, here father, mother, and son. So son is taking rest. Father is okay, he's making a call. Okay, so mother is doing some work. So just I have explained about this is a family what they are doing. Similarly, you will going to tell about that one. So this is a part is called the delay time. This is a part is called the delay time. So during the delay time, input voltage is rise from that minimum value into that saturate value. Here I have written bar. It is start to rise from that one saturation. So input voltage saturate is reached. That's all I have written. And don't go that one. Simple to I want to finish. So delay time is increased. This is increase. Start. Okay, it will going to rise from that one minimum value of the input voltage to that saturate value. Okay, this is called a delay time. What about the rise time? Rise time is nothing but a saturate level to the, okay, it is a further, it is a rise. So it is a increase. So it is saturate point to increase. That is about that rise time. That's all. So input voltage is over. Then coming to that one output voltage. Where is this the output voltage? What about the working of the delay time? During the delay time, it is a maximum value to reduce into the 90%, 100 to 90 or VCE to 0.9 VCE. So one value to the 0.9 value, it is a decreased. Okay, then next one, what about the rise time period? During the rise time period, further decreased from 0.9 to 0.1. So it's a further decrease into that 0.1. So 0.9 to the 0.1, it is a decreased, it's a moved. The next one, what about next output current? Output current during the delay time, it is start to rise from, it is start to increase from that one minimum value to that one 0.1 IC. So minimum value, what is the minimum value? That is called a leakage current value. Then here also leakage, minimum value to that one 0.1 is reached. What about the rise time 2 period? It is during the rise time period, it is further rise from that 0.1 to the maximum value. Yes, that's all. So you will going to, from the picture, you just see and start to write the tabulations. Okay, simple to say delay time. When you will going to write, you will going to write about this point. Now step number 1 you will going to write. This is step number 2 you will going to write. Okay, that's all. Very simplest one. Okay, what about off time? The same as it is off time also you can do. I make it as an off time. Off time is a combined 3. One is a delay time, delay fall time 1, fall time 2. If you want, you can refer this the page. Okay, very simple. I developed this tabulation just to see the tabulations. Okay, and then you will going to easy to can do that one. First one. Okay, delay fall time. This is a delay fall time. What about input voltage? Input voltage during that delay time. Okay, delay fall time, it is start to decrease from the maximum value to that V saturation VGET saturate value. Okay, what about the fall time 1? Further decreased. Yes, further decrease. What about fall time 2? Okay, from further decrease to the 0 value, it's a decrease. That means leakage current value. So up to the decrease into the 0. So input voltage is totally reduced. The next one you are going to say about that, what is the condition about that VCE? VCE means what about that one? Output voltage. Where is output voltage? This is the output voltage. This is a curve. During the delay time period, what will happen? During the delay time period, it is a maintained. So it is a maintained the positions. Okay. Then the next one, delay. Okay, delay fall time over. Then fall time period, it is start to rise. It is start to rise from that one, from here to the 0.1. So 0.1. Then the fall time 2 further rise from 0.1 to the peak value VCE. So it's a output of the voltage. So this is a condition. So what about the condition of that one? Okay, output current is you can look that pictures, just you will going to look yourself once. I will give the 10 seconds time. Yeah, yes, I will go ahead on that one. So it's a, what is this one? IC is a output current. So during this period, what happened? So this is a period is called a delay fall time. It is start to decrease. It is start to decrease from the IC to the 0.9 IC. It is start to decrease from that one IC to the 0.9 IC delay fall time. Yes, I have written in the table. Okay, I have written on the table. The next one. Okay, during the fall time one, it is 0.1 IC to 0.2 IC. 0.1 IC to 0.2 IC. Then otherwise simple to say 90% to 20% of the IC. Then further it is a fall time 2 period. What happened? Okay, 0.2 IC2, it is a decrease into the 0.1 IC. 0.1 IC, even 20% to 10%. That's all. So just you will going to see the diagram and then you will going to explain about that one concept. Is very simple to over. Okay. Then last part. Okay, it's a characteristics. So what is the characteristics you are seeing? This is a characteristics you have seen. Okay, this characteristics practically you will going to implement. Yes. So you will going to do what did you do for the MOSFET? The same method you will going to do for the practical implementations. So I have developed this type of diagrams. So this is called a power circuit diagram. See that one symbolism, IGBT symbol is used, a power circuit diagram. So without apply the gate terminal, it's whatever the voltage 200 voltage is applied, no use. 200 voltage is applied, but what happened? Switch is not closed. Why switch is not closed? Gate terminal is not applied. No pulse on the gate terminal. Okay, gate terminal is not triggered. Then trigger the gate terminals. What to do? So now I will going to give the power supply to the gate terminal. Okay, what will happen? Now gate terminal is closed. So gate terminal is applied. Switch is closed. Then this is a power is a flow. Closed circuits. So this is a method to control turn on. What about control turn off? Control turn off is power is like a cut and connected to the minus terminal. So it will going to turn off. The switch is open. So that's all. So this is about this. So far we have discussed about IGBT. So coming to that review. So just we're going to start review about that topic. Why IGBT is a voltage control device? Because input is it's a MOSFET is used. Its answer is the same. It's a combination of the MOSFET and IGBT. The input side is used. This device is called MOSFET. That's why it is a voltage control device. Okay, construction based. What is the difference between IGBT and MOSFET? If I have seen that one construction based on that MOSFET. MOSFET is a N plus NPN. So here is a NPN. So drain terminal, another one is a source terminal is connected. Okay, here is a gate terminal is connected. Through the capacitance you will going to connect it. Okay, this is a normal MOSFET. So this is a N plus layer is replaced into that one P plus layer you will going to constructed. So P plus, that's all, P plus layer you will going to form. N plus is replaced into the P plus, then remaining is same as it is P, then after that N. Then another terminal top is that one. What is that one? So collector terminal, another one is a emitter terminal. Okay, then here is a gate terminal, you will going to connect it, gate terminal as it is. It's a normal MOSFET as well as IGBT. Then here you will going to connect it for that one more, that is called N minus. That N minus is called a drift layer. That's all. So this is the second question answer. What is the difference between power and the frequency of IGBT and the MOSFET? So you know, I have draw for that first initially. So first unit, power versus the frequency. So who is the first rank in the power wise? So SCR is the first rank. Then second rank is GTO. Then third rank is members is who's that one? IGBT is the third rank. So third topest power thing. Sorry, what is the first one? First highest one is SCR. Then second one is what is that one? GTO. Okay, third one is IGBT. So compare with the SCR, it's a third rank. Okay, then compare with the MOSFET. MOSFET is a fourth rank in the power, but frequency wise MOSFET is higher. Compare with that IGBT. So this is differentiations. So what are the characteristics of the IGBT and the MOSFET? Well, not only IGBT, MOSFET, SCR, whatever the GTO you can take. There are two characteristics. One is a static, another one is a dynamic characteristics. Static and dynamic characteristics. Dynamic characteristics is nothing but a switching characteristics. What are the static characteristics? Static characteristics is nothing but what is the static characteristics? Static characteristics nothing but you will going to find out the output voltage and output characteristics and transfer characteristics. Output and transfer characteristics find out is called IGBT. Sorry, static characteristics. Next one, what is on time of IGBT and what is off time? On time of IGBT and then MOSFET is both also similar. It's a delay time plus rise time. Delay plus rise is called on time. Delay time plus rise time is called on time. Another one is off time. Is a delay fall time plus fall time. But that is called the MOSFET. Delay fall time plus fall time 1 and plus fall time 2. That is about that IGBT. So that's all review about the class.